So hi my students, hi my dear students. So today I am going to start differentiability or derivability. So what is the physical meaning of derivative? The physical meaning of derivative is it gives the instantaneous rate of change of the function. That means we can find the rate of change of the function with respect to its independent variable, and at a particular point we can find the rate of change of the function at a particular point. Okay, next, what is the geometrical meaning? So geometrical meaning of derivative is it gives the slope of the tangent to the curve at x is equal to a. So here a is some particular point. Okay, so next, so what is a tangent? Why we need to draw the tangent to the curve? So we need to draw the tangent to the curve. Why we need to draw the tangent to the curve? It gives the direction of the curve at that point. Tangent line gives the direction of the curve at a particular point. So also we know that tangent is a limiting position of secant lines. Now I am discussing left-hand derivative and right-hand derivative geometrically. So you consider y is equal to f of x and p is a fixed point a comma f of a, and q and r which are closer to p and they are also lie on the curve. Q is lies in left side and r is lies on right side, and these are the coordinates of p, q and r. Okay, suppose here I am going to find first the slope of PQ. What will you get slope of PQ using y2 minus y1 by x2 minus x1 formula? What will you get? F of a minus h minus f of a by x2 minus x1. A minus h minus a. It is equal to minus h only. So that is divided by minus h. Okay. Now, what happens if h tending to 0? So that means I'm applying, I'm going to find a limit of h tends to 0, slope of PQ. So what is PQ here? Secant line. So I'm giving particular name here. So as Q is a left side of P, I'm giving slope PQ as a secant line, which is the left side of P only. So I'm giving one name, left secant line through P. So PQ is a left secant line through P. Okay. So limit h tends to 0, slope of PQ is equal to what? Limit h tends to 0, f of a minus h minus f of a by minus h. If this limit is exist and finite, that finite limit is denoted by f dash of a minus, and this limit value is called left hand derivative of the function at x is equal to a. This f dash of a minus is called what? Left hand derivative of the function f at x is equal to a, and in this case we say that f is left differentiable at x is equal to a. So what is the geometrical meaning? Okay, what is the geometrical meaning of here f dash of a minus? So that means this f dash of a minus is what? Limit of this function as h tends to 0 only. But so what is the limit of this h tends to 0? What is the limit h tends to 0? What is this function? So this is nothing but limit h tends to 0, slope of PQ only. So that means when h is tending to 0, this point Q is approaching to P. The point Q is approaching to P. Then the secant line is going to close to what? Left tangent line. This PQ line is going to what? It is a left tangent line at P. Okay. And that means this f dash of a minus is nothing but limiting values of slope of the left secant lines through P. So it is the limiting values of slope of the left secant lines through P. Okay. Next, similarly, if I consider limit h tends to 0, slope of PR is equal to limit h tends to 0. What you will get? By using y2 minus y1 by h2 minus x1, slope of PR f of a plus h minus f of a by h. So if this limit is exist and finite, and this limit is denoted by f dash of a plus, and this f dash of a plus is called right hand derivative of f at x is equal to a. Right hand derivative of f at x is equal to a. And in this case, the function, if this limit is exist and finite, then the function f is called right differentiable function at a. So what is its geometrical meaning? So when h is tending to 0, that means the point capital R is going to close to what? P. So the capital R is going to close to what? P. Then the secant line is going to what? Tangent. Right tangent at P. Right tangent at P. So that means this f dash of a plus is nothing but, so the limiting values of slopes of the right secant lines through P. It is the limiting values of slopes of right secant lines through P. So if this limiting value and this limiting value, that is this f dash a minus and f dash a plus, both are equal. If both are equal, then this right tangent at P is same as this left tangent at P. Hence we can draw a unique tangent at P. So that is if f dash of a minus is equal to f dash of a plus, it is equal to some finite value, some finite quantity, then this left tangent and right tangent both are coincide, and it is possible to draw a unique tangent at P. And in this case we say that f is differentiable at a. That means if f is a differentiable function at x is equal to a, that means if left hand derivative is equal to right hand derivative is equal to finite value, then f is a differentiable at x is equal to a, and it is possible to draw a unique tangent at P having finite slope. This is the geometrical meaning of derivative of a function, both left hand derivative, right hand derivative of the function. So if both left hand derivative, right hand derivative are equal and finite, then we say that f is differentiable function at x is equal to a, and that common value is denoted by f dash a. So that is f dash a is exist, and this f dash a gives what? Slope of the tangent to the curve at P. At P, a comma f of a. Okay. So this is the geometrical meaning of left hand derivative, right hand derivative, and derivative of a function. Okay. So remember these definitions: f dash of a minus definition, f dash of a plus definition, and also this can also be written as, these two can also be written as. So this definition is also same as a limit x tends to a minus f of x minus f of a by x minus a. How we got this definition means put x minus a put a minus h is equal to x. Okay. And this definition also same as a limit x tends to a plus f of x minus f of a by x minus a. How we got from this to this means, in this case put a plus h is equal to x. Put a plus h is equal to x, then you will get this definition. Thus f dash of a is equal to, what is the formula? Limit x tends to a f of x minus f of a by x minus a. So if this limit is exist, then f is left differentiable and f dash of a minus is left hand derivative at a. If this limit is exist and finite, then in this case f is right differentiable and f dash of a plus is called right hand derivative of f at x is equal to a. If these two are equal, that means f is both left differentiable and right differentiable, and also left hand derivative is equal to right hand derivative, then we say that f is differentiable at a. Thus, and f dash of a is equal to, definition is this, and it gives geometrically what? Slope of the tangent to the curve at x is equal to a. And physical meaning is what? It gives the instantaneous rate of change of the function. That means it gives the rate of change of the function at x is equal to a, provided that f is differentiable. Okay. Next. After this, one important theorem. So remember f dash of a minus, f dash of a plus, both definitions of f dash of a minus, f dash of a plus, and the definition of f dash of a. Okay. And remember one important theorem. So we learned this theorem even in PUC also. If f is a differentiable at x is equal to a, if f is differentiable at x is equal to a, then this implies that f is continuous at x is equal to a. Continuous at x is equal to a. So that means differentiability implies continuity. Okay. And how to remember this means, anywhere we are familiar playing many games. In mobile also we are playing many games. So you consider completion of level 1 is continuous function. Not completion of level 1 is discontinuous function. Completion of level 2 is differentiable function. Not completion of level 2 is non-differentiable function. Then you can remember easily. So those who are completed level 2, they are already completed what? Level 1. That means the differentiable functions are always continuous functions. Suppose level 1 only is not completed. Is it possible to say level 2 is completed? No. That means level 1 is not completed means what? Discontinuous functions. So discontinuous functions are always non-differentiable. That means discontinuity or discontinuous implies non-differentiability. Suppose I'm unable to complete level 2. That means a non-differentiable. Okay. Is it possible to say level 1 is also not completable? Level 2 is not completed. I failed to complete level 2. That means is it possible to say I failed to complete level 1 also? No. That means non-differentiable functions non-differentiable functions need not be discontinuous. Need not be discontinuous. Also, continuous functions need not be differentiable functions. Okay. That means I completed successfully level 1. From that data, is it possible to say level 2 also completed? No. That means continuous functions need not be differentiable. They may differentiable, may not be differentiable. So those who are completed level 1 game, they may complete level 2, may not complete level 2. Okay. So differentiability implies continuity, discontinuous implies non-differentiability. Non-differentiable functions need not be discontinuous, and continuous functions need not be differentiable. So for both these two, counter example is f of x is equal to mod x at x is equal to 0. So f of x is equal to mod x at x is equal to 0. It is continuous at 0 but not differentiable at 0. Okay. See next. After this part, next. So I have to discuss next some important points. These are some important points. If possible, try to copy in your book also. Suppose f dash of a plus is p and f dash of a minus is equal to q, where p and q are some finite numbers. Okay. Suppose if P is equal to Q, that is the left hand derivative, right hand derivative both are equal, then we say that F is differentiable at x is equal to A. So obviously it is continuous at x is equal to A. Obviously it is continuous at x is equal to A. Suppose if left hand derivative and right hand derivative both are exist and finite but they are not equal, then what you can say, F is not differentiable at x is equal to A. And here it is very important thing is F may be continuous at x is equal to A. F may be continuous at x is equal to A. Remember, if both left hand derivative, right hand derivative are exist and finite but they are not equal, then we say that F is not differentiable at that point, but F may be continuous at x is equal to A. So remember, if F is not differentiable but it is continuous at x is equal to A, geometrically its meaning is the function or the graph of the function has a sharp edge at that point. The graph of the function has sharp edge at that point. That means the direction of the graph of the function, immediately changes at that point. So then automatically a sharp edge will form, then F is not differentiable. For example, mod x function same at x is equal to 0. Mod x function at x is equal to 0. Or if I consider this function, graph of this function. So whose graph this? This is the graph of mod x minus 1. Okay. And where we are getting sharp edge at x is equal to 1. So the function is continuous at 1 but not differentiable because the direction of the graph of the function at 1 immediately changes. So till left side of 1 the direction of the curve is in this. Left side of 1 is direction is this and right side of 1 is the direction is this. So both are different directions. So the direction of the curve immediately changes at that point. If F is differentiable, if F is not differentiable but continuous at that point means, so there is a chance of geometrically the graph of the function has a sharp edge at that point. Okay. So but remember one thing, if your function has a sharp edge at a particular point, so then F is not differentiable and continuous. Okay. But it is not required that both left hand derivative and right hand derivative must be finite. Okay. But in this case, if you find left hand derivative, you will get minus 1. Right hand derivative at 1, you will get plus 1. So both are finite values, but they are not equal. Okay. So but if f of x has a sharp edge at a particular point, say A, then at that point the left hand derivative, right hand derivative may be finite or infinite. It is not necessary that they must be finite only. Okay. Next important point. If f is differentiable at A, then it is possible to draw unique tangent at that point. So it is geometrical interpretation only, na? But if f of x has a unique tangent at x is equal to A, it is not necessary that f is differentiable at that point. Okay. If f is differentiable at A, then compulsory unique tangent at that point. There is no doubt. But converse, that means if it is possible to draw unique tangent at a point, then it is not required that f is differentiable at that point. For example, so at that point, function has vertical tangent. So if a function has a vertical tangent at that point, means slope of the tangent becomes what? Infinity. Slope of the tangent at that point, dy by dx is equal to what? You will get infinity. That means dy by dx is not finite. So we can't say y is differentiable at that point. So therefore, but tangent is exist. So function is not differentiable, but tangent is exist. Only in which case it is possible? only in case of vertical tangent. In case of vertical tangent, function is not differentiable, but it is possible to draw unique tangent. Okay, so differentiability implies that unique tangent, but unique tangent at a point need not imply that differentiable function at that point. Okay, next example for that is f of x is equal to x power 1 by 3. F of x is equal to x power 1 by 3 at x is equal to 0. At x is equal to 0, this function is not differentiable, but at x is equal to 0, it has a tangent which is y-axis. Okay. Next. So, how can a function fail to be differentiable? How can a function fail to be differentiable? So, in which cases the function is not differentiable? So, already we discussed. Left hand derivative, right hand derivative both are exist, they are not equal. So, in this case, function is not differentiable. Second case. So, function is discontinuous. If function is discontinuous, is it possible to draw a unique tangent at that point? No. So, function is not differentiable. Next. Third case, vertical tangent. Vertical tangent case. So, in vertical tangent case, whatever happens, the function is continuous at that point, but not differentiable. Okay. Next one more case, sharp edge. In sharp edge case also, function is continuous, but not differentiable. Okay. So, in case of vertical tangent, function is continuous, but not differentiable. Why? Because both left hand derivative, right hand derivative, both are tending to plus infinity or both are tending to minus infinity. But in case of sharp edge, function is continuous at that point. Then left hand derivative, right hand derivative, both may be finite or maybe infinite. Both are maybe finite or infinite. Okay. But in case of vertical tangent, left hand derivative, right hand derivative, both must be tending to infinite only, either plus infinity or minus infinity. Next two. So just like continuity, derivability on an interval. Continuity on an interval, we have learned. So just like differentiability or derivability on an interval. So a function f is said to be differentiable on open interval a comma b. If it is differentiable at each and every point on open interval a comma b. So all polynomial functions are differentiable. Okay. Next to closed interval a comma b. So when we say that a function is a differentiable function on closed interval a comma b. So just like continuity. So function must be differentiable on open interval a comma b, and function should be right differentiable at a and left differentiable at b. Okay. Function should be differentiable on open interval a comma b, right differentiable at a, left differentiable at b, because the function is not defined left side of a. So when we say that a function is differentiable at a at this end point, only it is right differentiable. So when we say that a function is differentiable at this end point, only it is left differentiable. Okay. Next one, when we say that a function is differentiable function, if it is differentiable at every point in its domain. And when we say that a function is differentiable everywhere, only if that function is differentiable on set of real numbers. So all polynomial functions, sin x, cos x functions are differentiable everywhere. Okay. E power x also differentiable everywhere. Whereas ln x, mod x, so they are not differentiable everywhere. But ln x is a differentiable function. That is, it is differentiable only in its domain. Next, mod x is not differentiable only at 0. Means at the rest of the points it is differentiable. Okay, and mod x is continuous everywhere. And in general, modulus of x minus a, it is not differentiable only at x is equal to a. Okay, just modulus of x minus a it is not differentiable only at x is equal to a. At the rest of the points it is differentiable, and it is continuous everywhere. Means the function is continuous at x is equal to a but not differentiable at x is equal to a. Okay, so that means if you want to check where this function modulus of x minus 2 is not differentiable, yes, at x is equal to 2 only it is not differentiable. So where this modulus of x plus 2 is not differentiable, so only when x plus 2 is equal to 0 or x is equal to minus 2. Okay, next this is also one important point. Okay, so this is also one important point. Okay, if f of a is equal to 0 and it is equal to f dash of a, that means f is differentiable at x is equal to a. Also f of a is equal to 0 and f dash of a is equal to 0. So then only we can say that mod f, is also differentiable at x is equal to a. So based on this point, one problem is given in previous advanced level. Okay, so if f is differentiable at a and f of a is equal to 0, f dash of a is equal to 0, then only mod f is also differentiable at x is equal to a. So for example, if f dash of a not equal to 0, then mod f is not differentiable. Though f of a is equal to 0 and f is differentiable at x is equal to a, but if f dash of a not equal to 0, then mod f is not differentiable at x is equal to a. Example, if I take f of x is equal to x cube at x is equal to 0, then clearly x cube is a differentiable function at 0, and also if you find f dash x, what you will get? F dash x 3x square, and its value is clearly 0 at x is equal to 0. So therefore modulus of f, that is modulus of x cube, it is also clearly differentiable at x is equal to 0. Whereas if I take f of x is equal to x at x is equal to 0, so clearly this f dash x is what? 1. Is it possible equal to 0 at x is equal to 0? No, it is not equal to 0 at x is equal to 0. So therefore modulus of f of x is equal to mod x. It is not differentiable at x is equal to 0. Okay. So remember, this is also important point. If f is differentiable at x is equal to a, such that f of a 0 and f dash of a is 0, then only modulus of f of x is differentiable at x is equal to a. If f dash a not equal to 0, then modulus of f not differentiable at x is equal to a. So with this I am going to close this session. So first watch this video, then you will watch next parts so that you can understand easily. Thank you.